The first paper that I would like to present is a multi-layer lesion-embedded ultrasound breast phantom with realistic visual and haptic feedback for needle biopsy, published in Q1 journal. Breast cancer is the most common cancer in women in the United States. It is about 30% of all new female cancers each year. However, many radiology residents in their graduate residency have little or no hands-on experience with ultrasound-guided breast procedures. To enhance safety, the Accreditation Council for Graduate Medical Education has strongly encouraged the increased use of simulation training in graduate medical education. In addition, stiffness and acoustic properties of breast tissue vary from individual to individual. Therefore, in this study, the tunability of the mechanical and acoustic behavior of the breast tissue mimicking material was investigated to develop a realistic breast tissue mimicking phantom embedded with simulated tumors in terms of haptic feedback produced during needle insertion and ultrasound imaging. Firstly, the granular, fat and malignant tissue sample were prepared using the breast TMM series suggested in the literature. Mechanical behavior of the TMM sample was then characterized through indentation tests at room temperature 25 degrees Celsius. Next, the Latin hypercube design method was conducted to evaluate the main components that affect the Young modulus of TMM. Based on total feedback, the suggested TMM from the literature were then tweaked to produce Young modulus similar to human fat, granular, benign and malignant tumors. Next, the phantom molds were designed using the SolidWorks and were manufactured through the 3D printing method. 2 silicone molds were produced to shape the simulated malignant and benign tumors. The shapes of the simulated tumor are defined according to the literature and the feedback from an experienced physician. The series of the suggested tissue mimicking material were used to develop a double-layer TMM breast phantom, which was embedded with simulated benign and malignant tumors. Unfortunately, simulated benign tumor could not be recognized from the ultrasound image. Only the simulated malignant tumor could be recognized. Therefore, to develop a breast phantom with realistic ultrasound imaging, the relative backscatter power of TMM was then further studied to adjust the contrast of the embedded tumor to the background granular tissue. Finally, suitable series of TMM for mimicking granular, fat, benign and malignant lesions were suggested and validated. The results show that the recipe of TMM could be customized to possess different acoustic and mechanical properties that conform to the inconsistency in real breast tissues. Other than that, we also developed a gelatin-based phantom for breast biopsy training. This study aimed to develop a low-cost and easy-to-fabricate gelatin-based phantom embedded with simulated tumors that could provide the resident with realistic haptic feedback. In the manufacturing of breast phantom, a rubber groove finger filled with the color solution, dry sweet potato, dry agar conjunct, and pickled shallot were used to simulate cysts, benign tumors, and malignant tumor respectively. The gelatin concentration was tuned to produce hardness similar to granular and fat tissues. The developed gelatin-based breast phantom was further validated in a workshop at NCKU Hospital. The questionnaire was used to collect the following information: the participants' level of previous experience with an ultrasound-guided core needle biopsy, the pre-instructional and post-instructional score of the participant, the participants' confidence level in performing the ultrasound-guided breast biopsy procedure without causing chest wall injury, and participants' overall satisfaction with the developed gelatin-based breast phantom. The profile of the participants ranged from trainees to experienced doctors. Significant improvement was seen across moderately experienced and inexperienced groups through training using the developed phantom. The moderately experienced group obtained the highest percentage of improvement in the confidence levels. Overall, the developed phantom was satisfied by the participants. The main property that distinguished the training phantom in the first and the second world is that training phantom in part 1 has the potential to be commercialized. Meanwhile, training phantom in part 2 could be DIY by the resident in the hospital. That's all for my presentation. Thank you.